It would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in all of physics. The announcement of a possible explosion from the Betelgeuse star in the coming weeks has generated an immense wave of excitement and intrigue in both the scientific community and the public at large. Michio Kaku, a renowned theoretical physicist known for his ability to explain complex phenomena in accessible terms, has recently shared predictions that Betelgeuse, one of the brightest and most well-known stars in our night sky, is on the verge of a supernova explosion. This event could have extraordinary consequences, not just for the cosmos but potentially for our solar system and Earth itself. Before we start, hit the like and subscribe buttons for more exclusive news. Betelgeuse, a red supergiant located in the constellation Orion, has long been of particular interest to astronomers. Its size and luminosity make it one of the most easily observed stars, even with the naked eye, and for years it has captured the attention of scientists due to its somewhat volatile behavior. Betelgeuse is nearing the end of its life, and while the timeline for its death has always been uncertain, recent observations have suggested that the star is undergoing dramatic changes. The dimming and brightening cycles it has displayed, especially the unprecedented dimming observed in late 2019 and early 2020, have raised speculations that its time might be much shorter than previously thought. If Betelgeuse were to explode as a supernova in the near future, the event would be one of the most spectacular celestial displays ever witnessed by humanity. Supernovae are among the most energetic explosions in the universe, and the sheer force of such a blast can outshine entire galaxies for brief periods. For those on Earth, the explosion of Betelgeuse could provide a light show unlike anything ever seen before. At its peak, Betelgeuse could shine as brightly as a full moon, visible in daylight for several weeks or even months. While such an event would be awe-inspiring to witness, Michio Kaku's prediction that the explosion could have a direct impact on Earth raises serious questions about the implications for our planet and the broader solar system. Supernovae are not just visually impressive, they also release massive amounts of energy in the form of radiation, particles, and shock waves. This energy has the potential to disrupt surrounding space environments, and depending on the distance and intensity, it could interact with Earth's atmosphere in potentially dangerous ways. One of the primary concerns in the case of a Betelgeuse supernova would be the emission of gamma rays and cosmic rays. Gamma rays are extremely high-energy electromagnetic waves, and in large enough doses, they could have catastrophic effects on Earth's biosphere. Fortunately, Betelgeuse is located around 640 light-years away, which is far enough that the gamma radiation from its explosion would likely dissipate before reaching Earth with destructive force. However, Kaku has pointed out that even though a direct lethal dose of gamma rays might be unlikely, the radiation could still affect our planet's upper atmosphere, leading to potential disruptions in satellite communications, GPS systems, and electrical grids. Cosmic rays, which are high-energy particles ejected from the supernova, could pose a more significant threat, albeit over a longer period. These rays can penetrate Earth's magnetic field and atmosphere, and while most are deflected or absorbed, an increase in cosmic ray intensity could lead to heightened radiation levels on the planet's surface. This could potentially have consequences for human health, particularly for those in high-altitude regions or frequent flyers. There is also the risk that an increase in cosmic rays could affect electronic devices and technologies, leading to malfunctions or failures. In addition to the immediate concerns of radiation and cosmic rays, there are broader long-term implications of Betelgeuse's explosion. One of the most intriguing possibilities is the effect that such an event could have on our understanding of stellar life cycles and the evolution of galaxies. Supernovae are critical to the process of star formation and the distribution of elements throughout the cosmos. The heavy elements produced in the core of a supernova are what seed future generations of stars and planets, including the very building blocks of life. Witnessing a nearby supernova in real time would give astronomers an unprecedented opportunity to study these processes in action. There is also the question of what impact a supernova could have on other nearby stars. While Betelgeuse is not located in close proximity to any major stellar neighbors, the shock wave from its explosion could still have ripple effects throughout the Orion constellation. This could potentially trigger star formation in nearby gas clouds, accelerating the birth of new stars. On a grander scale, the supernova could also provide insights into the formation of black holes and neutron stars, which are often the end products of such explosions. Despite the potential risks, Kaku and other scientists emphasize that a Betelgeuse supernova is more likely to be a scientific boon than a catastrophe. The wealth of data that could be gathered from observing the explosion and its aftermath would likely answer many lingering questions about supernova mechanics, stellar evolution, and the role of such events in shaping the universe. This would mark a profound leap forward in our understanding of astrophysics, as we have never had the opportunity to study such an event so close to home. The excitement surrounding Betelgeuse's potential explosion is also driven by its significance in human culture. For thousands of years, Betelgeuse has been an important fixture in the night sky, included in the mythology and stories of countless civilizations. Its sudden transformation into a supernova would be a dramatic change in the cosmic landscape, one that could serve as a reminder of the dynamic and ever-changing nature of the universe. For many, the explosion would be a poignant symbol of the cycle of birth, death, and rebirth that governs not only stars but all of existence. The psychological and social impact of such an event could be profound. Humanity has long been fascinated by the cosmos, and witnessing the death of a star up close would likely inspire a renewed interest in space exploration and science. It could foster a sense of cosmic unity as people around the world look to the skies in awe of the same celestial phenomenon. There may also be an increased awareness of our own planet's fragility and place within the broader universe, prompting discussions about our role as stewards of Earth in the context of an ever-evolving cosmos. One of the most intriguing aspects of Kaku's predictions is the timeline, just 2 weeks before the event occurs. While scientists have long speculated that Betelgeuse could go supernova at any time, predicting the exact timing of such an event is notoriously difficult. The fact that Kaku is suggesting such a short timeline indicates that astronomers may have detected significant changes in the star's behavior, perhaps through shifts in its brightness, size, or radiation output. These observations would be critical in refining models of stellar collapse and helping scientists better understand when and how supernovae occur. However, predicting the behavior of a star like Betelgeuse is far from an exact science. While it is clear that Betelgeuse is nearing the end of its life, it is also possible that the star could continue in its current state for decades or even centuries before finally exploding. The timeline for supernovae is notoriously unpredictable, and while the recent changes in Betelgeuse's behavior are certainly noteworthy, they do not necessarily guarantee that an explosion is imminent. Nevertheless, the prospect of witnessing such an event in the near future has captivated both scientists and the public alike. In the days leading up to the expected explosion, astronomers will be closely monitoring Betelgeuse for any signs of increased activity. Telescopes around the world, as well as space-based observatories, will be trained on the star to capture as much data as possible. This will likely be a highly collaborative effort, with scientists from various fields of study working together to analyze the incoming information and refine models of stellar behavior. In addition to optical telescopes, instruments that detect other forms of radiation, such as X-rays and gamma rays, will be essential in understanding the mechanics of the explosion and its aftermath. Public interest in the event will also likely surge as the date of the expected explosion approaches. News outlets, social media platforms, and science communicators will play a crucial role in disseminating information about the event, helping to educate the public on what to expect and what the implications might be. The explosion of Betelgeuse could become a global event, with people gathering to witness the spectacle from different parts of the world. Given the uncertainty surrounding the timing of the explosion, there may be a sense of anticipation and excitement as people wait to see when the star will finally erupt. For many, this event will also serve as a reminder of the unpredictable and often violent nature of the universe. While the stars in our night sky may appear static and unchanging, they are in fact dynamic objects constantly evolving and undergoing dramatic transformations. Betelgeuse's potential explosion would be a vivid demonstration of this fact, illustrating the power and complexity of the forces that shape our universe. As the anticipation surrounding Betelgeuse's potential explosion mounts, the scientific community and general public are filled with both excitement and apprehension. The possibilities and implications of this event are vast, and while Michio Kaku's prediction has drawn considerable attention, the broader scientific context surrounding such a supernova event extends far beyond the direct consequences for Earth. The potential explosion of Betelgeuse offers a rare opportunity for humanity to witness a cosmic event that typically unfolds over millions of years, condensed into a spectacle that could unfold before our very eyes. When it comes to understanding the full magnitude of a supernova like the one expected from Betelgeuse, it is important to recognize the scale of such explosions. A supernova represents the final death throes of a massive star, a process that can unleash more energy in a few seconds than our sun will emit over its entire lifetime. The blast wave from the explosion would travel outward at incredible speeds, eventually interacting with the surrounding interstellar medium and creating shock fronts that could spark new regions of star formation. The light emitted from a supernova can be visible across vast distances, and depending on the distance of the explosion, it could illuminate our night sky for weeks or even months. The explosion of Betelgeuse could also have cultural and philosophical implications. Throughout history, the appearance of new celestial objects or the sudden disappearance of familiar ones has often been interpreted as omens or signs by human societies. While today we have a far better understanding of the mechanics behind these events, the psychological impact of seeing such a bright and unusual object in the sky should not be underestimated. In a world increasingly dominated by technology and fast-paced lifestyles, the explosion of a star could serve as a powerful reminder of the awe-inspiring forces at work in the universe, forces that dwarf anything happening here on Earth. This explosion could also inspire a new generation of scientists, astronomers, and space enthusiasts, just as events like the moon landing, the Voyager missions, and the discovery of exoplanets have sparked public interest in space exploration. A nearby supernova could reignite humanity's curiosity about the cosmos. Schools, universities, and research institutions would likely see a surge in interest in astronomy and astrophysics as students are drawn to the mystery and majesty of space. The event could become a global touchstone, uniting people from different cultures and backgrounds in a shared moment of cosmic wonder. In addition, Betelgeuse's explosion could prompt deeper reflection on humanity's place in the universe. The fact that we can predict and study the death of a distant star speaks to the extraordinary advancements of human knowledge and technology. However, it also highlights the fragility of our existence in a universe filled with powerful forces beyond our control. Supernovae are common on a cosmic scale, but they are rare from a human perspective, occurring only once or twice in a millennium in our galaxy. Seeing one unfold in real time may remind us just how fleeting and precious life is, set against the vast backdrop of an ever-changing universe. On a more practical level, the event would likely lead to a massive mobilization of resources in the scientific community. Large telescopes such as the Hubble Space Telescope, the James Webb Space Telescope, and the European Southern Observatory's Very Large Telescope would be among the many instruments dedicated to studying the explosion. Space agencies like NASA, the European Space Agency (ESA), and private companies involved in space research might collaborate to gather data and analyze the event. There may even be efforts to launch new missions specifically designed to study supernovae, capitalizing on the wealth of information that Betelgeuse's explosion would provide. Furthermore, Betelgeuse's supernova could drive advancements in our understanding of high-energy astrophysics. The explosion would offer a rare opportunity to study the extreme physics involved in such events, including the generation of high-energy particles like neutrinos and the behavior of magnetic fields in the aftermath of a supernova. These particles, which are nearly massless and can pass through matter without interacting, are notoriously difficult to detect, but a supernova explosion would produce vast quantities of them, giving scientists a chance to capture and study these elusive particles. Neutrino observatories around the world, such as the Super Kamiokande in Japan and the IceCube Neutrino Observatory in Antarctica, would be on high alert for any neutrino signals originating from Betelgeuse. Detecting these neutrinos would provide direct evidence of the processes occurring in the core of the star during its collapse. Because neutrinos travel faster than light in a medium like the star's interior, they could offer an early warning system, alerting scientists to the explosion even before the light from the supernova reaches Earth. While the initial explosion of Betelgeuse would capture the world's attention, the long-term scientific value of this event could be even greater. The remnants of the supernova, the gas, dust, and elements ejected into space, would continue to provide material for study for decades, even centuries. These remnants would form a nebula, an expansive cloud of gas and dust that would serve as a laboratory for understanding the processes of star formation and the recycling of matter in the universe. Over time, this nebula could give rise to new stars and planets, continuing the cosmic cycle of birth and death. For scientists studying the origins of life, the materials ejected by Betelgeuse could offer new insights into the chemical elements that form the building blocks of life. Supernovae are responsible for producing many of the elements found in living organisms, including carbon, nitrogen, and oxygen. By studying the composition of the materials ejected by Betelgeuse, scientists could gain a better understanding of how these elements are formed and distributed throughout the universe. This knowledge could also inform our search for life on other planets, as we learn more about the conditions under which these essential elements are created. The explosion of Betelgeuse would not only offer a remarkable view of a nearby supernova but also open up an entirely new chapter in the study of cosmic events and their influence on both the Earth and the universe. As we delve deeper into the potential implications and broader context of this anticipated supernova, The possibilities expand far beyond the immediate impacts previously discussed. One aspect to explore further is the role of Betelgeuse's supernova in advancing our understanding of the fundamental forces of nature, particularly gravity. Betelgeuse is a massive star, and when it collapses, the sheer density of its core will significantly alter the fabric of spacetime. For decades, scientists have been eager to study gravitational waves, ripples in spacetime first predicted by Albert Einstein's general theory of relativity. Gravitational waves were directly observed for the first time in 2015, but most observations have involved events like the merging of black holes or neutron stars. A nearby supernova, such as that of Betelgeuse, would provide an unprecedented opportunity to study these waves originating from the core collapse of a dying star. Detecting gravitational waves from Betelgeuse's explosion could yield crucial data about the star's internal structure, particularly about how the collapse proceeds and whether the core forms a black hole or a neutron star. These observations would allow scientists to test Einstein's predictions under different conditions and refine their models of how gravity behaves in extreme environments. As advanced detectors like the Laser Interferometer Gravitational Wave Observatory, LIGO, and the Virgo detector become more sensitive, the ability to capture these subtle ripples from a supernova explosion would mark a significant milestone in the study of cosmology and astrophysics. Another aspect of Betelgeuse's explosion is the fascinating study of magnetism in the aftermath of a supernova. Massive stars like Betelgeuse have powerful magnetic fields, and when they explode, the collapse of the core and the intense forces involved can amplify these fields to extraordinary levels. If Betelgeuse forms a neutron star after its explosion, it may give birth to a particularly exotic type of neutron star known as a magnetar. Magnetars are neutron stars with magnetic fields 1,000 trillion times stronger than Earth's, making them the most magnetic objects in the universe. Understanding the processes that generate and sustain these magnetic fields is one of the open questions in astrophysics. Magnetars are known to emit bursts of X-rays and gamma rays, and studying a magnetar formed from Betelgeuse's collapse could provide key insights into the mechanisms behind these emissions. These magnetic fields also affect how the star's remnant interacts with surrounding gas and dust, influencing the formation of new stars and planetary systems. By observing the evolution of Betelgeuse's remnant, scientists could learn more about the role of magnetism in the life cycles of stars and galaxies.